Money, money, money. Nta kombe kuba busy semua. Good evening. Good evening. Can you all hear me? Oh, okay. If I'm loud and clear. Oh, okay. I'm not sure if there are still people who have to join or not, ne? So I would like us to wait maybe another 2 minutes to see if there will be other people who will join. Those who just joined now, I was just explaining that I will have to wait a little bit of 2 minutes to see if there will be other students who will be joining us. Okay, so the 2 minutes that I give other people to join, which means it's up. So I am Mr. Kosane. I will be with you in today's session. We will be reviewing or we will be doing Euclidean geometry as you were doing Euclidean geometry at school. So I would like to just show you some questions if that's okay. But then what I do like to do is to first review all the most of the theorems that are way more important that each and every learner has to know. Can everyone see my whiteboard?
Yes, sir.
Can we all see it?
Yes, sir.
Can you please not write on the whiteboard? We can all see the whiteboard, ne?
Yes, sir.
Okay, so if we can all see the whiteboard, which means we can start with today's lesson, ne?
Yes, sir.
So if all we can see the whiteboard, which means we can all start with our today's session, ne? So I do have a little bit of questions, ne, for you guys to practice. But then I would do like to review most of the theorems that you need to know or that you need to make sure that you know them by heart, ne? So in theorems, ne, the numbering doesn't matter. So as long as you can know the theorem that okay, this is the theorem when you look at the diagram, and then the naming doesn't matter whether this is theorem one, this is theorem two, or this is theorem three. Ne? So, oh, okay. If you can hear me clearly, can you hear me now? Which means maybe I'll have to raise my voice. Can you all hear me?
Yes, sir.
Yes,
Am I
sir.
audible
Yes,
enough?
sir. Yes, sir.
Oh, okay. So as I was saying, that in circle geometry, you need to know each and every or most of the theorems, ne? And the numbering doesn't matter, ne? So as long as you can know the diagram and then be able to explain that this is theorem what and this theorem what and this stays what, which means you will be on a right track, ne? So according to my numbering, I will start with this one. So according to my numbering, I will start with this one. I call it theorem two. So I call this one theorem two. I'll call this one theorem two, which states that I'll only write the reason. Ne? So I'll only write the reason. or only that reason, which states that the angle at center is 2 times the angle at circumference. Ne? So it stated that this angle is 2 times this angle. So this means that if this angle is x, and then it means that this angle here at the center, it is what? It is 2x. Ne? So you need to know this diagram, and you need to know somewhere, somehow, how to prove it like you did in class. Ne? So theorem 2 comes in 3 diagrams. So this is the first diagram. This one is the first diagram. And then it has a second diagram. Which still explain the same thing, that the angle at the center is 2 times the angle at the circumference. So it's either you see this diagram or you see this diagram. And then there is the third one. So this one, the third one, is different from the first two, because the angle that we are considering, it is the angle that's here. So we're saying now we're saying this angle that's here is 2 times the angle that's here. I hope now you see the difference, because now we were checking the angle that was between the what? Between the lines, between this line and this line. This line and this line. But now on diagram number 3, we are checking the other angle, not the inside one. Ne? So still say the same thing. This one, it's if sorry for that. So we're saying that if this is 2x, which means this one is going to be what? It's going to be x. So this is theorem 2 according to my numbering. So what you need to know is all these three diagrams, because most of them, they do come to exam, and most of them, they do come as like this one, as diagram number 1, and then they say that prove the theorem that state that the angle at the center is 2 times the angle at the circumference, which means you have to prove it. You know how to prove it. So you have to prove it by constructing a line from here down there, and then now you're gonna have to start naming some of the angles that you'll be given there. And then I won't dwell much on that. So sorry. Come again. Oh, okay. I can't hear you. Sorry for that, guys. Okay, sorry for that. So we are going to theorem 3. Ne? You just only have to know this one. Sometimes you don't really have to prove it. So it's theorem 3 on my numbering. let's say this is a center, and then this it's a diameter, and then
Yeah.
we have this. So it says that. Sorry, is this thing here or what? Benolia, can you please mute your mic? Oh, okay. Sorry for that, guys. So this one, when you encounter something like this diagram, and then it says here, let's say here it's E, and then here it's C, and then here it's A. So here they say that the angle A, it's 90, it's 90, it's 90 degrees. Because the reason is that is the angle at semicircle. So the angle at semicircle. I hope you can see what I'm writing because I'm having a problem with my pen. Yes. The angle at semicircle. This one you don't have to prove it. And then when it comes there on the diagram, which means you just have to recall that okay, this is this theorem, and then you have to know that okay, there it's what here at A, you have to apply that here at A, it's 90 degrees by seeing that this is a diameter subtending the angle at A at the circumference. So you need to remember this theorem that A is what? A, it's 90 degrees. And the reason is that it's at the angle at semicircle. And then we move forward again, and then you need to know this one. So this one, we usually call it theorem 4. We usually call it theorem 4, which states that the angle subtended by the same arc or the same chord to the circumference of the circle are equal, which states that if this CD is an arc, and then CD subtend angle A to the circumference and subtend angle B to the circumference, which means that angle A is equals to angle B because they are subtended by the what? By the same arc. So the reason for this one, you just say angles at same segment. Angles at same segment. So this applies to even if we're focusing on the other thing, if we're focusing on arc AB, arc AB, arc AB subtends the angle to C and to D, which means again that we have C, which equals to D, and then is the what? Is the same reason. Angle at the same segment, or angle subtended by the same arc or the same chord, or angle subtended by the equal chord, like this. If you have a diagram and then you have this, and then you have this. So they're saying that if these two chords are equal, so they're saying that if these two chord A, B, and CF, if these chords are equal, and then it means that angle C is equals to angle D. Now the reason is still gonna be the angles sub by equal what? Now it's gonna be equal chord, because by the what? By the chord, not an arc. So which means equal angle subtended by the what? By the equal chord. So you can just write the chords here. You say could AB, it's equals to C, it's equals to CF. So yeah, it's equals to C, it's equals to CF. So which means this theorem, you have to know it, the angle at the same segment. And then we have another few. So I'm just gonna write this two here. We have this one, we call it theorem 5, and then we have this one that I will draw here, we call it theorem 6. So theorem 5, you can prove it, but then it doesn't really come to the exam. So theorem 5, it says that if A, B, C, D, it's a cyclic quad, and then which means it says that the exterior angle of a cyclic quad, it's equals to the opposite interior angle. So when you see a question, you just need to make sure these all theorems are there and identify which are not there, so that it can be easy for you to answer the questions. Ne? So this is it. So the reason here is that is the exterior angle of cyclic quad. Exterior angle of a cyclic quad. And then let's go to diagram number 2, which we call it theorem 6, still fall under the Vanilla, are you saying something? We are still together, Mus. Are you guys still following?
Yes.
Oh, okay, so we have this one again. So if we have A here and then we have B here, and then we have C here and then we have D here. So this one is stated that the opposite angle of a cyclic quad are supplementary, which means that if you add angle A with angle B, they're gonna have to give you 180 degrees. If you add these two, they're gonna have to give you 180 degrees. So the reason here is because of what? Opposite angles of cyclic quad. Opposite angle of a cyclic quad. So that's the reason there. So it also stated that even this one, even the B and C, they are also what? They are also supplementary. So you can even state that B also B plus C, it also equals to 180 degrees. It's the same reason. Opposite angle of a what? Of a cyclic quad. And then we have an application of this theorem. You just have to know that it's this way. If this line is a tangent, so let's call this line AB. So AB is a tangent at C. AB is a tangent at C. And then we have the center of the circle, and then we have a radius that goes to the point C. So this one is just an application which says that a line from center to the point of contact with the tangent, which means that line is perpendicular to the tangent. So you just have to know that a line from center or a radius or a diameter is perpendicular to what? Is perpendicular to tangent. So when you are identifying, state a reason why this angle is 90 degrees. The reason it's a radii or a radius perpendicular to tangent. So that's the reason. And then we have again this diagram, it involves the tangent also. You guys are still following us?
Yes, sir.
Okay, so if we're still together, so this theorem, it's only stated that the tangent from the same point to the circle, they are equal in length. So it means it stated that AP it equals to BP. So the reason that they're equal is because they are from the same point, and both of them they are the tangent. They are the tangent to the circle, and you can prove it by constructing a line from here to P, and then you prove congruency. Since you have the triangle OBP, and the triangle OAP, and then you can really identify that this line it's equals to that line. You have a common line that you constructed, and you have the other side, which are the radius OA and OB. Are you saying something? And then you have the what? You have OA, which is equals to OB. It's because this one are the what? Are the radius, since O is the center of the circle. And from this last showed you, I just showed you this one. It did says what? It says a radius perpendicular to a tangent. It gives us an angle, which is what? Which is 90 degrees. So which means when you come to here, which means you have an angle here, because this is a radius and this is a tangent, and they come to a point of contact at B, and this one they come to the point of contact at A. So which means now you have the side, you have the side, you have the side, you have this side, and you have this side, and then you have this side and that side, and the angle, which means now you can conclude that these two triangles are what? Are congruent, meaning that this side is equals to that side. So are the tangent from what? Tangent from same point. So that's the reason why AP is equals to BP, tangent from same point. And then we have this one, it's also involve the tangent. And I do hope that you know all this one. C, D, E. So this one says that the angle between the chord and the tangent, the angle between the chord and the tangent, the chord and the tangent, it's equals to the angle that's in the opposite side that the chord subtend. You see? So which means this angle it's equals to that angle. So it's say that the angle between the what? Between the chord and the tangent it's equals to the opposite interior angle that the chord subtend. So we have BDC, which is equals to angle A, and we can give the reason, which you all know, that it is what? It is tan chord theorem, because we're talking about the what? The tangent and the chord. And then lastly, we have these two. A line from center drawn to the midpoint of the chord. To the midpoint of the chord, it's perpendicular to the chord. We all know this one. Yeah. So they are saying that a line drawn from center of the circle to the midpoint of the chord. So which means once it's a midpoint, which means it divides chord AB into a line. That line, we can call it line OC. It is perpendicular to AB. So
This is what the theorem says. So if a line is from center and it's drawn to the midpoint of the chord, which our chord it's AB, and then that line is perpendicular to the chord. Ne? So don't mistake these two theorems. So this one says that a line from center perpendicular to the chord, a line from center perpendicular to the chord, even though my diagram doesn't look like that's the center, but then like yeah. So a line from where? From center perpendicular to the chord, and then that line it bisects the chord. So here they're saying if a line is perpendicular to the chord, which means that line bisected the what? Bisected the chord. So if it bisected the chord, it means that A, C, B. So the reason here is because of what? The reason is that you can just write OC is perpendicular to A, AB, or you can just name the statement in shortcut, or a line from center perpendicular to the chord. And even here, you can just name the reason as a line to the midpoint of a chord. So you can just like make it shorter that way. So you can just say here, here you can just say here you can just say OC bisect AB, and then this can be the reason. So I think I'm done reviewing the Euclidean geometry. So let me see if I can have the questions that we are going to all participate in answering, and then tell me if you can see the questions. Ne? Can we all see?
Yes, sir.
Can you all see clearly?
Yes, sir.
Oh, okay. So if we can all see it clearly, so which means all of us we are going to participate in trying to answer these questions and see where we are lacking. Ne? So the question says, in the figure, O is the center of the circle A, B, C, D. O is the center of the circle A, B, C, D, E. And then we are being told that DB it equals to DF. So this one it equals to this one. We are being told that, and then AODF, BOE, and BFC are straight line. They say that AODF AODF is this line, this straight line. So we are being told, Guri, that's a straight line. So what comes to mind is that it's a straight line which is passing through what? Passing through center. You see? So which means now you can conclude, Guri, you see A O D. Do you see A O D? AOD passes through center, which means that AOD is a what? It's a diameter, which means, and once a diameter subtend an angle to the circumference, that angle is equals to what? Huh? Unmute your mic and talk, or you can just text, just type there. If a diameter subtend an angle to the circumference, that angle is equals to what? Huh? Naleri, are you here?
Yes, sir.
So, okay, so here it is. So once a diameter subtend an angle to the circumference, that angle is equals to 90 degrees. We just did the theorem here. Here it is. The one I just named, Gore, it's theorem what? It's theorem 3. This one. The diameter passing through center, it subtend an 90 degrees angle. So it is being called the angle at semicircle because the diameter divide the circle into 2 equal halves. Ne?
Yes, sir.
Yes. So before you can just do anything, you just have to identify the theorems that are there in this diagram so that it can be easy for you to what? To answer, and then you can isolate, okay, my answer are based from this theorem to this theorem. Ne? So when we look at this at this diagram, we can see that we don't have a what? We don't have a tangent, all right? So
Yes.
once we don't have a tangent, which means we have eliminated about like 3 theorems. We have eliminated the 3 theorems. We have eliminated the turn chord. We have eliminated the turn chord. We have eliminated the turn chord, this one, and we have eliminated this one, and again we have eliminated this one. You see, we have eliminated 3 theorems. And then there you go. And then now you do have center, and then which means now you are only focusing on the what? On the theorems that include the what? That include the center. Because when you check here, you are not told that anything here it's a what? It's a cyclic quad. So which means again you eliminate which theorem? You eliminate this theorem and this theorem. You see? So which means now you are left with these theorems from here up, from here up, from here, yes, from here upwards. So which means you are left with theorem 2, theorem 3, theorem this one, the angle at the same segment. You see how it is, Mos? So you have to first identify the theorems that are there in the diagram. and then it can be easy for you to what, to answer the questions that are being asked. Can you please stop moving there? Oh, okay. So let's answer. Let's answer. They say calculate, giving reasons, the size of the following angles. Then they say D2, D2, D2. This is D2. Here is this 2. Here is D2. Here is D2. So when we look at D2, the only way we can relate it is to F, because we are given an angle F, which is what? Which is 10 degrees. So once we are finding the size, which means it's gonna has to be a specific unit. So once it's a specific unit, and here on our diagram we only have one unit. So which means we have to relate D2 to F. So how can we find D2 if we relate to F? But then we can just look to the triangle. We can just look to that triangle. If this is D, and then this is F, and then this is B, I think. So here we have what? We have 3. Yeah, I think it's 3. And then here we have 10. And then here we have the 2. And then remember, we were told that dB it's equals to dF. So what can you conclude from this? What can you conclude from that diagram? From triangle BDF, what can you conclude? Let's talk. Let's talk. Just unmute your mind and then just say, what can you conclude when you have this triangle, when you're having this triangle? What can you conclude? Are you guys gonna say something? Oh, okay, so what we can conclude is that B3 it equals to angle F, where angle F is equals to 10 degrees. Can anyone see it? Can someone just state the reason why I said B3 is equals to F? Anyone who's gonna state the reason? Is there anyone who can tell me the reason why I said B3 is equals to F? Let's all participate, please, so that we can move on to 7 point.
So, exterior angles of a cyclic quad.
So the exterior angle of a cyclic quad, that's where it covers it covers, that's where D2 has to be equals to the sum of these two angles. But then now I'm asking why did I wrote that B3 it equals to F?
Opposite equal angles.
Yes. So is the
Angle.
angles that opposite equal what? Equal side. So once you do know that even B3 is 10, which means now it is going to be easy for you to do what? To find D2, because someone just mentioned it now, Corey. We have D2, which is equals to the sum of these two. It's equals to B3 plus F, because it's what? It's an exterior angle of a triangle. You see? So, which means now you can find D2, which is what? So, since B3 is 10 degrees and F is 10 degrees, which means we can find our D2 to be what? To be 20 degrees. Do you all understand? Meaning that we can move to,
Yes, sir.
we can move to 7.2.2. Okay. So what I'm gonna do is that I'm gonna erase this so that I can have the space to write and then still see the diagram. Ne? So let's go to 7.2.2. We are still finding the what? The sizes of the angle. So now they say find the size of the angle A. Angle A. This is angle A. This is angle A. So how can you, so which means angle A falls under how many triangles? It's 2 or 3 or 4 triangles. Ne? It's triangle ABO. You see? Do you see ABO? Triangle ABO, and it falls under triangle ABD, and it falls again under triangle ABF. So it's up to you which triangles that have the two known triangle in the two known angles, so that you can identify the third angles. The third angle. So, or which triangle I can find the second angle so that I can find angle A. Ne? So that's what has to come to mind first. So when you look at this one, we have just got D, so which means somewhere somehow D has to be related to what? To A. So it works like that. Once they go on logic, which means the first one is related to the second one, and the second one is related to the third one, and the third one is related to the other ones above. So when we look at A, and then we look at the triangle ABD, triangle ABD. When we look at triangle ABD, and not forgetting that AD It's a diameter. So, like I said, if you did identify the theorems that are here, which means we do already know that this angle is what? It's 90 degrees through what? Through, because the diameter subtends the 90 degrees angle at the what? At the circumference. So we can just easily answer, we can just, that's the first statement. When we look at this triangle, we have D2 here and we want A. So we can easily state that this angle, we do have it. You see, which means now we'll be having two angles, which means we can find the what? The third angle. So we have angle, they said they named it angle B1, I think. Yeah, they named it B1. So we have angle B1, which is equals to 90 degrees. This is the first step that you have to write when answering A. And then the reason says that is the what? Is the angle at semicircle. The angle at semicircle. You see? So which means now you have two sides that you know in this triangle. So which means you can easily find the what? The third side using the what? The sum of the angle in triangle. Do you see that? So which means now you have what? You have angle A plus angle D2 plus angle B1. No, it's not B1. Why did you guys leave me and write B1? It's ABD. It's angle ABD because it's this whole angle. Yes, it's that whole angle. You see, you guys are not participating. Why didn't you find that mistake? Okay, so which means it's angle ABD, which is equals to 180, which means these are the angles in what? In triangle. So it's either you write angles in triangle or you just write the sum of angle in a triangle. Ne? So now you're gonna have to substitute your answers. So you want A, and then you have D, which was 20. You have D, which was 20. And now you have what? You have ABD, which is 90. So which means your A, it was 280 minus 90 minus 20, which leaves our A to be what? What's A if you minus 90 and 20 from 180?
70.
Yes, that's 70 degrees. We all understood, Musi. Do you all get it? Did you all see how we arrived at A?
Yes, sir.
Yes, sir.
Okay, which means we can move forward to finding the size of O, the size of O2. So I'm gonna erase it. I'm gonna erase this. I just hope you were writing it. So I'm going to send this question to Mr. D, and then I hope that you will send it in a group, and then you guys can go use it to practice again, and then just do it on your own and see that yes, you can do what we did in class. So, and then let's go to 7.2.3. They're saying that find the size of O2. So once you see that it is 2 marks, you see, it is 2 marks, which means you only have to state the statement and then you state the reason why, the reason that support your statement. So the reason why you say your statement is that. So when you're here, they say find the size of O2. And then when you go here, here is O2. Here is O2. So is there anyone who can like just give us an idea how to find O2? Anyone? Anyone who can give us an idea how to find O2? Anyone? Oh, okay. So let's do it like this. So let's do it like this. O2, when you look at O2, you can only relate it to triangle BOD or BOF. That's the only way you can relate O2, or you can relate O2 as like what? As like triangle what? ABO. So, but then you are using the theorems. So, which means sometimes you have to use the theorems and then just leave the characteristics of the triangles and all the stuff. So when you look at the theorem which states that the angle at the center is 2 times the angle at the circumference, I showed you the second diagram. I showed you a second diagram which was like this. So you don't see something like this in the diagram. Even though it's not like this, it can be like this. Can be like this. Do you all see it? So which means this angle is 2 times the angle that's there. Do you see it?
Sorry. Which angle?
Oh, okay. So when we come to the diagram, we are talking about BD. Do you see BD? BD.
Yes, sir.
BD subtend an angle at the center. You see? Subtend an angle at the center. And again, BD, it subtend the angle at the circumference. Do you see it?
Yes.
Yes. So which means that this angle here is 2 times the angle that's here.
Yes, I see now.
Do you all see it?
Yes, I see, sir.
Oh, okay. So which means now you can just easily write that O2 is equals to 2A. And then you write your reason that angle at the center 2 times angle at circumference. Alright, so you see what I told you. I just said, Guri, the second answer or the third answer or the third question will depend on the previous 2 questions. And if you can see, we did use what? We used A to find O, and we used D2 to find A. So you see, it goes on like that. Now we are going to use another what? Another, it's either we use O or we use any of the other, it's either we use A or D or O to find our angle, which is what? Which is C1 there. Do you see it?
Yes, sir.
So I'm just gonna erase these diagrams only. And then we are gonna go to 7.2.4. Now they find the size of C1. C1, what is C1? Here's C1. Yes, there is C1. If you can look at C1, how do you find C1? How do you find C1? Do you remember the third diagram of the theorem that says that the angle at the center is 2 times the angle at the circumference? The third diagram, this one,
Yes, sir.
that says this angle is 2 times this angle.
Yes.
When you look at C, can you relate it to this diagram? When you look at angle C, can you relate it to this diagram?
No, sir.
Oh, okay. So here's the thing. You have O2 here. You have O2. O2 which is equals to what?
Is equals to 140.
O2 is equals to 140.
Yes.
Yes. So you have O2 here. You see? You have O2 here. So, which means for you to use this, okay. Sorry. So for you to use, so if you have this angle, this one, if you have this angle, what did you need to do to find the angle that's the other angle there?
To find C1.
Yes. So when you relate C1, it's a half this angle. Ne? So, but in other way, we can say this angle. Let me erase and show you. So you have C1 here. So C1, it's a half of the angle that's here, which means that the angle that's here is 2 times C1, right?
Yes.
And the only angle that you are having is this angle that's here. Is the angle that's here.
The
So,
center.
which means you can find this other angle, this one, the one that's
Yes.
around there. So using the what? Using the angle around a what? A point.
Yes, sir.
Yes, I agree. This is a point. So we do know that that angles around a point are called are called what? Are called revolution, right?
Yes.
And that equals to what? 360. So which means after finding the angle behind here, after finding the angle that's behind here, which means now you can find what? You can find C1 because the angle that's behind here is 2 times what? It's 2 times C1. You all can see most. So, which means here we have O2, we have angle O2 plus, so the other angle, I'm just going to call it BOF. BOF. This whole angle, I'm just going to call it BOF plus BOF. That equals to 160 degrees. So it's either you say it's a rev, which stands for revolution, or you just say angles around a point. So the reason I'm including all these other angles is because what I'm focusing on this. You see?
Yes,
I'm
sir.
focusing on that. So which means I need this whole angle to identify what? To identify C. You see?
C1. Yes, sir.
Yes. So which means we have our O2, which is 140 plus BOF, and then which is was what 360. Which means our BOF is what?
Two
Is
240.
eh?
220.
Is
220.
220.
Yes.
Yes. Which means it is 220. So and we do know that BOF is equals to 2 times C1. You see?
Yes, sir.
Yes. So the reason is what? The angle at the center is
Is
2
equal
times the
to
angle at the circumference.
circumference.
At the circumference.
Yes.
So which means now you have what? You have now you have 220, which is equals to 2 C1, which means you can divide by 2 now and then get what? Get C1,
110.
which is equals to 110.
10. Yes.
Yes. So that's our C1. And then let's see if we can find E, and then I will send the question, and then you will finish the rest on your own.
Yes, sir.
Yeah. So if we look again on the question, they say find the size of E. What is E? Okay, let me bring it down. Okay. E. Let me erase whatever that's here so that you can all see. E. Where is E? E. There's E. There is E. How do you find E? How do we relate E to the other questions from C up to D2? How do you relate E? Yeah?
is okay. It's on the same point with O. Use this triangle, say ED, B,
EDO.
EDB.
Oh, EDB. Oh, you do have D, which you can say
D,
it's 90 degrees,
OE.
but then you don't have B. You don't have B3. Do you have B3?
Yes. No,
Eh? We don't have
no.
B3. Can we find
Yes.
B3? And remember, it's
We
only
only
2
have
marks.
3. Yes, sir.
So remember, it's only 2 marks, which means it's a statement and a what? And a reason.
And the reason. Yes.
Yeah. Okay, but then do you see this theorem? Okay, I won't go up. I'll just have to write it here. Do you see this theorem?
Which one?
This one, the one that I'm drawing now.
Oh, yes, sir.
The one that says this angle is equals to this angle. Do you see something like
Yes.
that there?
Yes, sir.
Do you see it?
Yes, sir.
So if you do see it, which means that angle A here it's equals to angle what?
E.
Angle E. Because they are both subtended by the what? By BD. You
Yes.
see? BD
Yes,
subtend
sir.
an angle at A and it subtend an angle at E. So which means you do have the answer there. So which means you have E, which is equals to A, which is equals to 17, eh?
70, sir.
Yes. And then angles at same
Segment.
segment. Yes, angle at same segment. And then you can see that you can find C2. It's either you find C2 using the straight line that's here. You see it?
Yes, sir.
Yes. You find C2 using the straight line, or you just find another way that you can find what? C2. But then remember, you have to check the marks.
Yes, sir.
Yeah. So this is the end of our session. And then I'm going to send this question paper to Master, and then he's going to send it to you so that you can finish writing. Yeah, so that you can finish writing 7.2.6 and 7.2.7 and see if you can find them on your own.
Thank you, sir.
Thank you.